A very good morning to everyone over here. I'm Kazi Zainab and I'll be speaking about the topic that we brought about, that is identifying the health-related occupations of Twitter users through word embedding and deep neural networks. So we have actually selected Twitter because it's an extremely popular social networking site where tweets or short messages of Twitter users are extensively researched. However, there is not much research that has been done in terms of the biographical contents that are provided for each of the public Twitter users, especially in mining their professionals. In our work we have done is mining the medical professions from the biographical contents, and this can be extremely useful for building recommender systems and also cost-effective targeted advertisement. However, it is extremely challenging for traditional classifiers to predict the medical occupations accurately, since it involves predicting multiple occupations of users. And thus, we emphasize on predicting the medical occupation class of users through their public biographical content, which is known as their bio content. And we have conducted our analysis by annotating the bio content of Twitter users, and that's why we propose a method of combining word embedding with the state-of-art neural network methods that includes a long short-term memory, LSTM, bidirectional LSTM, gated recurrent unit bidirectional encoder representations from transformers, in short known as BERT, and also a light BERT, which is also in short known as Albert. And also we have observed that by composing the word embedding with the neural network models, there is no need to construct any particular attribute or feature. And before starting about the proposed method of how we did it, I wanted to discuss about the related work that has been done in this field. And so we know that a dataset was already constructed by Pietro, where they have assigned 9 hierarchical business job categories, and also there is Alotros and Chamberlain. They have extended the dataset by following the connections from the users of the occupation datasets, and they have used embedding, which is used as an input into the classification model. And then Pan et al. Have also used the network's informations and their bio descriptions of the Twitter users over the tweets for predicting the occupations of users, and gotten and obtained an accuracy of 61%. And specifically for classification tasks, deep neural networks have also demonstrated that they perform better than conventional machine learning methods, especially recurrent neural network, which is an enhanced model of DNN, that is deep neural network. It examines each of the words in the corpus and stores the semantics of passwords inspected in hidden layers. And also it has been used for document level sentiment classification and then for sequential short-term classification. However, we know that RNN has not performed that much significantly well in memorizing text from distant, which means that it cannot remember any word which is at least 5 words behind the word that is currently being memorized. And thus, in order to solve this sort of issues, LSTM and GRU models have been introduced. They're extremely effective since these models have can remember and learn text which is needed rather than memorizing longer text, since they involve having forget gets, especially LSTM. LSTM has forget gets which can only remember the important words that are needed and forget the words that are not necessary for it. And also bidirectional LSTM has also been introduced, which runs inputs in 2 ways, one from the previous text and also from the upcoming text. And bi-LSTM have shown to outperform LSTM as at any point they can preserve information from the not only from the previous context but also from the future context. And most recently, BERT has been introduced, which is a bidirectional model, just like bi-LSTM. Its major component is that it uses bidirectional transformer language model while training on textual data. Especially, it has masked language modeling and next sentence prediction that increases the quality of the classification model. However, it involves a lot of parameters since it has been trained on millions and billions of words. And so when it comes to processing and remembering and training, it actually takes a lot of time, and that is why a more upgraded version has been introduced, which is called the Albert. It actually has since it involves a lot of parameters, Albert was introduced to solve this issue. It has the same architecture as BERT. However, Albert uses two-parameter reduction techniques to significantly decrease the number of training parameters of BERT. And so in this paper, our task is mainly a multi-class text classification problem where we want to identify the most likely medical profession for a given user based on their biographical content. So thus we have at first generated a vector space model in which each vector represents the unique tokens of each biographical content, and then what we did was we fed the vectors directly into LSTM, BILSTM, GRU and BERT neural network models respectively, and these models perform multiple classification identifying the occupation of the users, and our results have shown that the neural network models along with vector space models have performed well in identifying the medical professions from their biographical contents. And so in our approach, at first from the unlabeled raw data, a term index vector space model was generated in which the vectors represent the positions of the unique tokens in the textual data, and then a sequence of vectors representing each biocontent is produced using the VSM and is given as an input in the LSTM, BILSTM, GRU and BERT neural network models respectively, which executes the multi-classification task. We had first converted our occupation classification into a sequence of classification problem so the task can be managed more appropriately by the neural network classifiers. And thus, one of the major drawbacks of textual data is that it cannot be directly converted into text vectors, as the terms from each text tend to have a lot of variable lengths. And so for solving this issue of representation of words, padding was introduced. In the vocabulary, the text cannot be directly represented as vectors, and so the unique tokens are placed with their indices, and also they're formatted in this way as dense vectors. And so for the data that we have used for training our model was built from the Twitter biographical data. We have built our data that maps into specific medical occupations based on the biographical content, and we have also used those accounts, especially from the medical accounts, like medical Twitter accounts, so that we can get more concentration of users in medical professions. And also we have annotated their description fields, and we have mapped them according to the National Occupation Classification NOC, which is provided by the Canadian government. So, and we have specifically used that because we wanted to know that because it has more recent occupations in their list, and that is why we have used their taxonomy for mapping the medical occupations of the users. And so at first, for processing the data, we have used the vocabulary, and the VSM was created from non-annotated biographical contents and were represented as sequence of dense vectors, and then we classified the contents with LSTM, BILSTM, GRU, BERT, Albert network models respectively. In this process, the model at first searches in the vocabulary for the locations of the biographical content terms and tracks down the required dense vectors from the location information, and finally the vectors are arranged accordingly for generating a sequence of term index. And so in this paper, our task is mainly a multi-class text classification problem where we want to identify the most likely medical profession for a given user based on their biographical content. So thus we have at first generated a vector space model in which each vector represents the unique tokens of each biographical content, and then what we did was we fed the vectors directly into LSTM, BILSTM, GRU and BERT neural network models respectively, and these models perform multiple classification identifying the occupation of the users, and our results have shown that the neural network models along with vector space models have performed well in identifying the medical professions from their biographical. And so in here I'm going to actually explain about the architecture of the model. And in here we can see that the text of each biographical content is compiled as a sequence of 67 term index, as 67 was the largest number of terms collected for each of the contents, and each index was formatted as in 128 dimensions. So we have actually selected 67 as our vector term because this was the maximum number of words for each of the bio content. And so for each text, a sequence of 67 vectors of 120 dimension was fed to each of the neural network models. So in here, this is the text that we have obtained, which is the by content. So in here, one user has described himself as a pharmacist, professor, and specialist in geriatrics. So this was converted into indices in the vocabulary, and it was padded into 67 vectors. So this was its vector positions, and then it was actually rendered with 128 dimensions. So at first, in the first layer, it was fed, and this is a neural network model. So in here, the neural network model actually represents LSTM, BioSTM, BERT, Albert respectively individually, and then at last we have fed it into the dense layer. And so in here you can see the output probability will be to predict the desired text in the final layer. And we have actually have input units of 128 dimensions and output units at 128 dimensions as well. And in each of the models was trained individually, and the accuracy was recorded in each of the epochs. We have observed that the accuracy became stable at around 15 epochs. So on average, for all the models, we have selected 15 epochs for training our models. And so basically for our model, in order to validate it, we have calculated recall accuracy and precision weighted scores, and we have evaluated the performance of our approach of combining word embedding each of the models respectively. And also our data set was highly imbalanced, so we have used weighted metric scores to consider the label imbalance issue, and the results have shown that Albert has performed significantly better compared to other neural network models, and Albert has achieved the highest accuracy, precision, recall, and F1 score. So in here we have shown the table of the metric scores, and also we have calculated the training times. In here you can see that as Albert only uses parameter reduction technique, so it actually takes quite less time compared to BERT, and out of all the model, BERT takes the most amount of time to train with the data. And also from here you can see that Albert has actually achieved high accuracy, precision, recall, weighted F1 weighted score as well. And also then, so we have actually arranged it in ascending order, and also we have compared it with the machine learning models as well, which includes naive Bayes, logistic regression, and stochastic gradient descent as well. And in here you can see that the deep neural network models have performed especially way better than the traditional machine learning models. And so we can see that Albert, BERT, BioSTM, LSTM have achieved higher precision scores compared to the recall scores, which suggests that the models predicted more true positives than false negative. And besides, the GRU model has higher recall value compared to the precision, which shows that GRU can correctly identify more true positives and fewer false negative. And so basically our research has shown that by composing word embedding with neural network models, it has outperformed the conventional machine learning classifiers. And moreover, traditional classification methods depend mostly on features developed by human intelligence, which can be extremely challenging to design, and thus text classification texts can tend to become very slow when there is a burden to construct any particular attribute or feature, or when it especially involves feature engineering. Thus classification text we have observed can be executed much faster when there is no need to have any sort of there is no need to design any feature or specific attribute. And also in the future, the medical occupation dataset can be further extended by adding the network features from each of the users, and the network features can be pre-processed from their follower and following ID from each of the users, and the features generated from the social network graphs from each of the users can further contribute to improve the occupation prediction of the users. Thank you so much. I hope you have enjoyed the work that we have brought about. Have a nice day. Thank you.